Hi everyone. So, uh, as of now, let's have a discussion what we did till now. So, we first try to understand what is generative AI in NLP, right? Then, text generation process we did through transformer, right? Through transformer we did this thing. Thereafter, word encoding we understood. Using the thereafter we went for the from word encoding we went to word embedding, okay, and we had seen how word can be converted into vectors, okay, and then we worked on the text classification. Now it's time for text generation using RNN, right? That means, see, I'll give you a first explanation and thereafter we'll try to work on it, right? See, as of now, what we did, if I have any text, okay, like text is like I like the movie. Now it's like I want to train a model which can identify this as a positive or negative sentiment. So what I have to do, I have to convert this thing into vector. This also will be converted into vector. Okay, this is what we did. Some numerical value will be there as a vector. Okay, like this. Okay, like this. This will be converted into vector, right? Okay, and this will also be converted into vector. Okay, something like this, right? Now these values will go to neural network. We have how many neurons? We have 12 neurons, right? So there will be a 12 neurons, 6, 7, 8, 9, 10, 11, 12, right? And these 12 neurons will get these values like 0.1, 0.2, 0.3 kind of thing. Okay, up to 0. Whatever 9, like this. Over here 0.9. There will be a hidden neurons. Okay. Now the how many hidden neurons will be used, that depends upon your model is getting overfit or underfit. Okay. If it is getting underfit, we increase the number of hidden neurons. If it is getting overfit, we decrease the number of hidden neurons. Okay. These hidden neurons helps my neural network to learn about these what weights. Okay. And thereafter there will be output neuron. All of them are connected. And this output neuron value is calculated as y hat, and then error is calculated as y minus y hat. Then error get optimized by tuning these values of weights. Your algorithm will tune the values of weight so that your error can minimize and your output can be as close as possible to real value. This is what we discussed. But what about if I want that my system should, my algorithm should not just learn weight, it should also have the memory. Okay, it should also have what is memory actually? Just allow me for a minute. Okay, so just a minute. Ramanna is trying to get in his. Wait a minute. Ramanna, you joined? Just a minute. Ramanna is. Wait a minute. I'm just trying. Ramanna is facing issues. Ramana, you got the mail. Ramana, can you are you there? Ramana, are you there?
Yes, yes, yes. Now I joined.
Fine. You just check your mail, the mail ID that you have used during the registration. On that mail,
Okay.
you got a invitation, right? If you join through that mail, I don't have
No.
to accept you, right? You can automatically
Oh,
join.
okay, okay. Sure, sure, sure. Let me check that. Tomorrow onwards, I'll do that.
Right. No worry, it's fine. So now, so these guys are what, it's like we are feeding the text over here, but these guys are only learning the weights. That means it is not learning about that. Suppose I have a text over here. I like the movie. So this model is not having any information that what is present before the, okay, or what is present before like, okay, or what is present after like, okay, what is present after the, right. This particular model is not having that information. Okay, this model did what, just learned about these weights. Okay, and once it learned about these weights, using those weights, it is further making the predictions, right. It is not having the information of the sequence. Okay, that is time stamp based learning is not happening. Okay, time stamp based learning means what, actually whenever you write any text, okay, you write a text like this. If this is your time t, this is your time t, then this is your time t minus 1, this is your time t minus 2, okay, this is your time t plus 1, right. So this information is very important if I want to predict the next word. Okay, if I want to predict the next word, a model should have this kind of information. Okay, like say next word, if this kind of information will be there, my model can easily predict the next word, like I like the movie watched. Okay, now this is a new word predicted. Now based on the this word, okay, this whole information, it can predict the next word today, like this, right. So if my model is having the memory of what, memory of past word, okay, the sequence, the past sequence, it can easily predict the next word, right. And that is possible through a neural network which is called recurrent neural network. Okay, so what we build over here, what neural network that we build over here, this neural network is called deep neural network. Okay, we build the deep neural network. Okay, now we have to build what, recurrent neural network. Recurrent neural network is dedicated for what, for the text. Okay, if I have to build a model which is learning from the sequence, it can be any sequence, it can be a text sequence, it can be audio sequence, it can be any kind of sequential data. Okay, if I want my model to learn from any kind of sequential data, then what we use recurrent neural network. Okay, the architecture of recurrent neural network works like this. There will be one set of neural network, there will be other set of neural network, then there will be other set of neural network, like this. Now let's say I have the sentence movie was good, right? So we feed the in this unit, that is unit 1. Okay, unit 1 we feed what, movie. Okay, in unit 2 we feed what, was. In unit 3 we feed what, good. Unit 3 we feed what, good, right. So this unit is responsible to learn only about the movie. As of now, what we were doing, we were just feeding everything over here, right. That's why it is not learning about the sequence of the data. Okay, but we feed it like this. Now what we do, when we feed the information over here, this unit will learn something, and the output of this unit will be given to the next unit, like this. An output of this unit will be given to the next unit, like this. Now what will be there within this unit? The question is, I'm telling you this unit, but what present inside it? Okay, let's try to understand what will be there within this particular unit, isn't it? So how neural network, like suppose if I have a movie, so if I want my model to learn about movie, so first I have to convert movie into a vector, right. Let's say this is a movie which is converted into a vector like this. 0.1, 0.3, 0.7. Okay, like this. Okay, 0.1, 0.3, and 0.7. And there will be a hidden neuron like this, and their output neuron. Right. This is what we do as per the current understanding, and then model will try to learn about these weights so that at the end it can, kind of make some prediction out of movie. Right. Now what we do, we will just turn this thing, whatever the structure that you see over here. Okay. This structure we will just turn like this. This structure we will turn it like this, like this. Okay, and then we feed the here, sorry, here we have to feed the information about the text. That's it. Okay, that means this whole structure we will turn it like this over here. Okay, it's very simple way to understand it, right? Here it will be like this. Okay, here it will be like this. Okay, so now we will feed one word to a single unit. This will just these particular weights will just try to understand about the movie, right? And then next we'll try to understand about was, then good. So in this way, when you prepare your neural network will have the weights, okay, to know about a particular word, as well as because of this kind of sequential architecture, it will also have the memory of word in with respect to timestamp. It knows that your model will at the end will knows that how the words are arranged, how the words are existing in the data. Okay, like after like deja was. Okay, so with the was, what kind of words are present? With the was, before was, what can be there? He can be there, right? He was, I was, she was. Okay, these kind of words will be there before was, right? So it what the model will learn about it, that was is a word, before was, these are the words which are having the highest probability, right? Same way after was, according to your data, whatever the things that, like suppose I'm using this data, let me show you a data also. Okay, let's say I'll show you a data. Okay. Let's say, because I have to train a model on the text, so I require text data. So let's say this is my text data. So similar to it, I can use any text data. Now, if I'm using such text data, model will know what will learn that how the words are arranged according to a text data. After was there may be 2 words, 3 words, 5 words, or 7 words, or 100 words may have been used. Okay, but out of 1,000 words, out of 10,000 words, there may be 100 words maybe there afterwards. Okay, afterwards, it's not like that all the word is possible afterwards. Okay, in your data afterwards, there may be 10, 20, 100 words may be there. So now model will have the memory that, okay, afterwards there are, what are the words that are having the highest probability, right? Like, afterwards it's like he was traveling, okay, singing, right, eating, like this, whatever, right? So this architecture helps the model learn about the sequential information. Okay, and if it learn about the sequential information, it can easily predict the next word in the sequence, right? It can easily predict what next word in the sequence. So overall, the architecture works like this, where here I will feed the input, okay, input 1 at timestamp t1, okay, then input 2 at timestamp t2, input 3 at timestamp t3, okay, and then it will learn about the weights like this, and those weights it will just learn about over here, and here is the output, okay, output 1, output 2. Right. That means the next neural network over here, okay, that is responsible for the was. Okay, the next neural network over here that is responsible for what? responsible to learn about was. Okay, like this. Okay, over here like this, right? So this neural network will also have the information about the previous word. Okay, like the previous word we are feeding over, let's say movie, right? So this movie output, okay, whatever the output this guy is generating, so this output is what? This output depends upon all the weights that we have over here, right? That means ultimately this output, is having the information about all these weights, right? So this output will also go to this place, okay, and from here it will just attach it like this, attach it like this. So this is an additional weight that will be present. Okay, this will be the additional weight that will be present, so that this neuron will also learn the weights along with the weights from the previous time stamp, and same process will go to the next unit, right? So this kind of neural network, when we create, we call it what? RNN neural network. What? Recurrent neural network, right? So recurrent neural network basically exists in four types. Okay, the first type that we had already seen, first type is a simple one that we already created earlier. Okay, that is the first type of recurrent neural network is what? One to one. Okay, this is the first type of neural network. One to one means what? Just like we created earlier. Simple. We have one input and one output. Just one input and one output, like we created earlier. Okay, this is what we created here. Okay, in this thing, last day that we created, that was if I'm talking about one to one, so one to one is very similar to what we did here. Okay, we are just feeding over here one input. Okay, here it is. Uh, okay, so we are just feeding over here one input, okay, and expecting just one output. That's it. That is what one to one. Okay, so one to one is like simple one that we already worked upon. Thereafter, we have one to many. Okay, so one to many is something which is different. Here we have one input, okay, but the output can be many. Okay, so where it can be used? It can be used in a kind of a information. Let's say I give the text data, and from the text data, I want to identify the, kind of some place. Okay, like I have an input data. From this input data, I want to identify that in my text, what are the popular, or you can say some places are mentioned, like India, USA. Okay, or in my text, like say this particular output will recognize all the places. Okay, then important persons, important or popular person, like some prime minister or something like that. So this will identify important person, right? I want to identify from here, let's say, important points, important points. Okay, like for example, out of all the things that we are learning, okay, at the end we get the session summary, right? So in the session summary, different outputs are there. Okay, we throughout the things we are giving the information, but at the end we get the session summary that is giving me that what actually happened in the last session. Okay, everything. So it's like one to many. We had given one set of data, and from set of data, many things being identified. Okay, like it identified that we had some audio issue earlier. Thereafter, we discussed one embedding. Thereafter, we discussed text classification. Thereafter, we discussed data preparation. Thereafter, we discussed neural network model. Right. So this is kind of a one to many. Or one more example. Let's say I have an image. Okay, and in that image, we can have, kind of a multiple things may be there. Like suppose there is an image of traffic, right? So image of traffic will have what? Image of traffic will have the image of bus, image of cars, image of traffic lights, right? Image of traffic lights, image of lane, image of kind of persons, right? So in a single image that we are feeding, there are multiple entities present. Okay, so this kind of model can recognize all the entities separately, right? So this is called one to many, right? Thereafter, many to one. Many to one is like, we can create a uh, neural network, a RNA neural network, in which we are feeding up many words. Okay, and then at the end, I want the sentiment. Sentiment as positive or negative. I want the sentiment as positive or negative. That's it. That is many to one. Okay, that means the model that we created over here last day, this was the similar model we can create using RNN. Okay, here we created through deep neural network. Okay, this is working good because our text size was not that big. It was a very small text we use. Okay, but if I have a little bigger text, okay, little longer sentence, then we have to use RNN over here, right? So RNN, similar things, similar kind of model we can create through RNN, right? Next we have many. This is called many to one. Okay, next we have what? Many to many. Okay, so where do we use many to many? Or many to one will also be used for text prediction or text generation, right? Like for example, here I am feeding up the things like I like traveling, and I have to predict the next word. So next word, like I have given three words, three inputs. The next word is can be like I like traveling more often. Okay, next word predicted can be what? Often, right? So many to one can be used there also, right? And last it is many to many. Okay, many to many actually works like this. We have many input, okay, and we will have many output as well. Okay, so this is used in what? In translation. Okay, this is used where? In translation, like English to Hindi translation or something like that. Okay, because we are feeding multiple words and all the words will be converted into other language. That is many to many. All right. So it depends what are actually what kind of application we have to create. One to one to many to many, or many to one. Here we will use many to one. Okay. The for the next case study, we are going to use what? Many to one. Okay. We will build a model which will take our multiple text input and predict the next word, generate the next word. So it's like many to one. All right. So why RNN is required? Because RNN not just learn weights, it is also having the memory, right? Why RNN is required? Because RNN not just learn weights. Weights helps a RNN to know about a particular word. Rather, it will also have the memory of the sequence. If we are feeding the sequential data, so that sequence, it will have the memory of that sequence, so that it can later on use to predict the generate the next word. All right. So let's try to implement it. Okay. So to implement it, what we do, we will use over here. First of all, we should know how to read the text data. Okay. We can implement it, that's fine. But first thing we should know over here is how can we read the text data. So let's first read the text data. Okay. So let's say this is your text data that we may have to use. You can use any text data, right? So first I'll give this link to you. If you want to download it, you can download it from here. It's simple to download. Here is the download button, right? I'll download it. Download it. Now I'll go to my download folder. Okay, India underscore U. So I guess I have downloaded earlier as well. India. Yes. Okay. So this is text data that I have to use. If I have to use this text data, step one, I have to upload the text data into Colab. Okay, because I'm using Colab. If I'm not using Colab, if I'm using my offline tool, then I don't need to upload. Directly I can access from my system. But here we have to upload. Okay, so here we are uploading our text data, right? Once the text data is uploaded, what we do next? we will try to read this text data. Now, with this example, we will also learn about the Python file handling. Okay, so we'll open this thing. We'll just copy the path over here. Okay, open function basically used to open any particular file that we have in Python. Okay, so before any machine learning or deep learning model that can be trained on the text, the first thing we need to do what? The raw data must be loaded and processed. So we are loading up the raw data, right? Next, we have to feed over here read, right? So see, whenever we are working on the file handling, that means I want to read the file in Python. Okay, so we can do what? We can write a file. Just a minute. Okay. We can write a file. Okay, we can read a file. These two things we can do. Okay, so if I have to write a file here, I have to use W. But here file is already there. We don't have to write it. We are reading it. So we are using R. Okay. Now we will just store this thing into a variable called my text. Okay. So now if I will just print my text dot read, so it should show me the data, right? So that means I can successfully read the data into the Python environment. Okay, so if I can read it, what I can do, I can just store this thing into a variable that is my text. Okay, I just store it over here, right? And once I stored it, that means here, actually both sides we should not have the same variable. So better I should use over here my file. Okay, and here my file dot read. Okay, so now we can do what? Once I read the data, the process we should use what? We should close the file. Otherwise, this will use extra resources, because once you read, you close the file. So this is how we close the file. Now, if I will call my text, I can see my data file over here. So the data that I want to use for the training purpose, now I have that particular data. All right. Okay. So once we have the data, what we do next? I want to build a model which can learn about it, right? So what we should do next? Next, we have to, just like previously we did, we have to do the tokenization. Okay. Always, this is one of the steps we have to do anyway. Okay. Always we have to do this tokenization. Okay. Here we are using it through program. Okay. Later on in agentic AI, we will use it with the help of some inbuilt tools. But we have to do it. Some way we have to do it, either by program or tools or anyway. Okay, tokenization is something which is always we have to do, which will just access each word from the given text. Right. So how we perform the tokenization? We did it from TensorFlow dot text dot what? Keras dot preprocess TensorFlow dot Keras dot preprocessing dot text. This is what. So this is a library we are using it for the, I guess, third time. Right. Now, how tokenization this works? We have to define an object for it. Right. So my tokenizer. Okay. So this is the object. This will be equals to what? Tokenizer. Okay. Thereafter, my tokenizer dot fit on text. This is your function we are using or method we are using, right? And what is your text over here? My text. All right, right. Now we can see what the once it is done, and I'll call what the dot word index, isn't it? Once it is done, fit on text, then dot word index, right? So I can call my tokenizer dot word underscore index. All right. So when we call it, I'll get each word will be assigned a each unique word will be assigned a particular numeric value. Right. So this one we can store into a variable called word underscore index. So this is an initial processing we have to do in each and every text data that I want to use for building up a model. Right. If I have to build a model, then this is what we have to use each and every time. All right. Okay. So you can consider it like this. This is one of the first step. Okay. Now we have to do what? We have to check how many total words are there. Okay. So how many total words are there? That would be length of word index. Okay. 598. We have total 598 unique words. Okay. In this text data, we have 598 what unique words. Right. Now, as we have 598 unique words, then what we can do, we can just add 1 into it. Why? Because 0 is not there. And you know, when we do padding and all, okay, when we do padding, 0 will be added. So 0 should also be counted. So total number of words will be, okay, total number of words. Now, why we did plus 1? Okay, in case if you forgot it, please let me tell you. See, this is what we did, right? Here, to make it structured, we are adding 0. That is a padding, right? So this 0 should also be counted, right? That's why we are doing it. All right. So total number of words will be over here 599, right? So here, print vocabulary, vocabulary size. Okay, what is your vocabulary size over here? Total number of words. Okay, 599. Okay. Now, okay, one more thing. Let's say if I want to have this is my text, right? Okay. So this is the my text, right? Now in this my text, you know, if I want to check any single line, how can I check a line? Okay, see, there is a split function of string. Okay, split. Okay, dot split. Okay, and here we give the reference for the splitting. So let's say I'm giving the reference for the splitting as a space. So when I had given the reference for the splitting as a space, what we got? We got all the words are separated over here. Okay, and we are getting the list of words. Okay, so instead of a space, if I will split based on new line, slash n represents what? New line. Okay, so here we are splitting the text based on the new line. So these are the lines. Okay, now why we did it? Because as I told you, we have to build a model which can predict the next word. Okay, like we are giving some 2 or 3 words. So using those 2 or 3 words, it should predict the next word, right? Like suppose I just had given the remark. Okay, I had given the model the word the remark. Okay, so my model should predict the next word will be may, then not, then be kind of thing. And in this way, it should complete the sentence, right? So that's why we are basically capturing each individual line one by one. Okay, each individual line we're just capturing one by one. Okay, like this. Here also we are capturing the individual line. Here also we're capturing the individual line. So it's like we're capturing each individual line one by one. That is very important. Okay, because what I told you, here the RNN will try to learn about the sequence, right? So it will learn about the sequence. So how it will learn about the sequence? if we have to feed you have to feed the sequence, right? So the sequence that we feed over here like this. So first we'll feed following, then we feed A, then we feed Lavis, then we feed sentence, sorry, state, right? So to feed the sequential data, we need what? We need each sentence to be separated, right? Like first we feed all the sequence from the first sentence, okay? Then we feed the sequence from the second sentence, okay? Then we over here feed the sequence from the second sentence, like this. Then we feed the sentence from the sequence from the third sentence, okay? Then we feed over here sequence from the third sentence, like this, isn't it? So in this way, we keep feeding the sequence one by one. All right, that's why we are doing it. Okay. So let's say here I have the lines. So I'll just store this thing into lines. Okay. And in case if I want the first two lines, so this is showing us the first two lines. Okay, this is your first line. Okay, and if I will go to the end, so this is second line, which is obviously blank. Okay, then we have a third line, we'll have some word, some sentence. Okay, first line, then after there is a blank. Okay, then there is a third line. All right. Okay, fine. So now we have to do what? We have to build a model which can predict the next word. So how do we build it? So we build it like this. See, if I am feeding the following, okay, so I expect my model to predict A. Okay, if I feed over here following A, so I expect my model to predict what? Lavis. Okay, if I feed over here following A, Lavis, then I expect my model to predict state. Okay, if I feed over here following a Lavis, state, okay, so I expect my model to predict visit, right? So in this way, this last column, okay, can act as a target variable. Okay, this will act as a target variable for my model. Okay, because a machine learning will learn from two things. One is called feature, another is called target or label. Okay, it learns from the two things. Machine learning learns from what? Two things: features and labels. Like in the last example also, what we did, we were having over your features, and then for each feature we were having the label, right? So machine learning model were trying to learn the relationship between this feature and the label. Okay, a machine learning model were trying to learn the best relationship between the feature and the label, isn't it? So that's why here what we have to do, we have to create a target or a label, right? And this is a feature, but it is unstructured, no problem. We'll do the padding over here. Okay, so now my algorithm needs to learn about the information that we are giving over here, that is the feature and the label. What is the best relation between these things, and who will help it to learn? The RNN, that is recurrent neural network. Okay, and once it learn it, it can easily make the prediction of a word. So here what we feed? We feed the word vectors. Okay, here we have to feed the word vectors. And word vectors comes from what? Comes from the numerical value that we created. Okay, that means now we have to create a data like this, which can be used for learning. Okay, we have to create a data like this, which can be used for learning, right? So it should, be kind of a meaningful, so we will just use we'll just create this thing for the first sentence, then we create it for the second sentence, then we create the same thing for the third sentence, then we create the same thing from the fourth sentence, right? That means I have to pick each sentence over here one by one. What we have to do? We have to pick first one each sentence one by one. So for line in lines, print line. So it's like we're picking each sentence one by one. This is the first sentence. This is the second sentence. This is the third sentence, fourth sentence, fifth sentence. Right? We are just picking each line over here one by one. Okay? Right? Now, each line information I have to convert into number. So who is converting into number? This guy is converting into number. My tokenizer dot fit on text. Okay, this guy had already converted into number. Now this numerical value I have to convert into sequence. So how can we convert into sequence? Yeah, see here. First, this guy did what? Is identified the number for each word or given the number to each word. This thing had given the number to each word. And thereafter one more function that is converting it into the sequence. So we'll take it tokenizer dot. Okay, let me comment this thing and paste it over here. Tokenizer, not tokenizer. This time it is what? My tokenizer. This time we are using what? My tokenizer. So here also my tokenizer. Okay. So my tokenizer dot text to sequences, and we feed over here what? The line. Okay. So let's do it. So my complete sequential data, which is a text converted into the numbers. From where this number is coming up? This number is coming up from here. Okay. So this my tokenizer is actually knows about the number of each word in the text. As it knows about the number of each word in the text, it is creating a sequence of numbers. All right. But the sequence of numbers, if you see present, how it is present? You can see this is one square bracket, then the second square bracket, right? So, it is, if each line is there in two-dimensional form. Okay, it would be better if it would be in a single dimension. That means if it would be only this much. This external square bracket is not that much required. So what we can do, this external square bracket, and then we have, anything, suppose over here like this. Okay, like this. 3, 2. If I want this value, so this is index 0. Okay, this is index 0. That means, see, this is the external square bracket, right? And this is enclosing this particular sequence of numbers. So let me go to the end. Okay, and here it is closed. Okay, so you can see the square bracket opened there, closed over there. So I want the info. That means this is external square bracket. Within the external square bracket, we have only one list, and I want that list. So I can use what? Index 0. Okay, what I can do, I can just use over here index 0. I did index 0 at wrong place. Index 0 should be within print. Okay, so now we have what? Just a single dimensional. This is representing first sentence, then there is a blank space, then second sentence, then blank space, then third sentence, blank space. All right. Okay, so this value we can store in a token list. Okay. Now what we do from here, now we have to do something which is a little interesting over here. I'll show you. Fine. So if you see here, we have a value 99, 4, 177. All these are representing words. So first we capture only 99 and 4. Okay. Next we capture over here. Okay, let me just do it like this. Okay. So first we capture over here only 99 and 4. Next we capture 99, 4 and 177. Next we capture 99, 4, 177. 50. Next we capture 99, 4, 177, 50 and 34. Okay. Next 99, 4, 177, 50, 34 and 28. Right. So that for each we will have the sample, and for each sample we will have the target node. Okay. Like this. Just a minute. Okay. So now, okay, so these things will act as a feature, and this is the target. This is a feature, and this is a target. That means when I just feed 99, I want my model to learn that after 99, 4 is there. Okay. When I feed 99 and 4, I want my model to learn that after 99 and 4, 177 is there. Okay. So this is what we have to do. Okay. So how can we do it? Again, we'll get back here. Right. Here what we did, we created a loop which is accessing each line one by one, because this is containing the complete lines. Okay, all the lines in the data. So using the loop, we are accessing each line one by one. Okay, and then we converted them into a sequence of number. Fair enough. Now what we do, from each line we capture 2 word, then 3 word, then 4 word, then 5 word, then 6 word, like that. Okay. So what do we do here? For uh, for token in token list, or just a minute, let me think of it. Mm, hmm. The logic is not like that. Actually, here we have to use range function. Now, if you are known to range function, it will be easier for me to tell. If you don't know, let me tell you. Here we will use a range function to run a loop. Okay. For loop we did what? Here we did a for loop directly. Right. For loop we can create one more way, which is called range, or I in range. Okay. 0, 10. So the value of I will be what? Well, it starts from 0 and go to next 10 steps. This is your for loop in Python. Okay. The value of I starts from 0 and goes to 10. All right. So here we will use the same thing. I'll tell you why it will be used. For I in range, okay, 0, okay, what should I use here? 10, 20, 30, 40, 50, what? How many times I have to run the loop? Okay, see, if I have a sentence in which, let's say, I have only, 10 words. Okay, let's say I have a sentence, and in that sentence I have 10 words: 99, 4, 177, 50, 34. Okay, let's say 5 words. Okay, so what I have to do, I have to create like this: 99 and 4, 99, 4, 177, 99, 4, 177, 50, 99, 4, 177, 50 and 34. Right. So this is what I have to create. Okay, like this. Okay, so it's like, and then it is done. So now my model can easily learn from this data. If 99 is the input, then 4 is output. If 99, 4 is input, then 177 is output. Okay, so how many times loop is running? The loop is running for 4 times. Okay, what are we doing here? This is index 0, 1, 2, 3, 4. Okay, that means in the first loop, okay, in the first loop, we are capturing index 0 and 1. In the second loop, we are capturing index 0 and 1 and 2. Here we are capturing index 0, 1, 2 and 3. Okay. Here we are capturing 0, 1, 2, 3 and 4. Right? So we are starting from 1. That means we have to capture this thing first. So I can write a loop that will start from 1. Okay. I can write a loop that will start from 1 and I have total 5 words. So 1 to 5. Okay. So when I run it, 1, 2, 3, 4, I'm getting over here. What I'm getting for I in range 1 to 5 is 1, 2, 3, 4. The value of I starts from 1 and going for total 4 steps. Why 4 steps? Because 5 minus 1 is equals to what? 4. Right. Here 5 minus 1 is what? Is equals to 4. Right. So my value of I starts from 1 and go for 4 steps. So here, first I want the value up to index 1. This will control. Next, I want the value up to index 2. This will control. Next, I want the value up to index 3. This will control. Next, I want the value up to index 4. This will control. All right. So every time the number of values that we want, we are just changing over here. So it's like we're starting from index 1 and we have to run this loop that would be equals to number of value in a particular sentence. So that would be equals to length of token list. Okay. So the value of I will start from 1, okay, and goes up to the extent, that means how many values are there in a particular sentence. All right. And then what we do, we'll create over here print from that particular token list that we have. Token list is representing what? Token list is actually this is your token list. Okay, this is a token list of first sentence, this is a token list of second sentence, token list of third sentence, token list of fourth sentence. So we'll take the token list, okay, 0 colon index I. Okay, 0 colon index I. Okay, so let it be done. Okay, so here what we get, let's see. It is giving you the values like this. Okay, I'll explain it. Let me go to the first. Okay, so first it captured 99. Okay, why it captured 99? See, we were having the sequence like this: 99, 4, 177, 50, 34, like this. Now I said what? Run the loop for 1 to length of whatever the length of that particular sentence. Then we picked up the token list. Token list. Okay, given over a 0. 0 means what? The first 0 index colon the value of I. The value of I is what? 1. Okay, 0 colon 1 means what? 0 colon 0 plus number of steps. Number of steps. Okay, so that means it starts from 0 and take 1 step. So that's why 1 value. Okay, next time the value of I will be what? 2. As the value of I will be 2, so it will be 0 plus 2. So it starts from 0 and take 2 steps. Okay, then next time it will be value of I will be what? 3, because we are running a loop. That loop will increase the value of I. So take the 3 values. Right. So the process over here is like this: I colon, I should use I plus 1. Then only I can have this one first. Because if I will use this one, so there is no target over it, there is no label, it's just only one thing. What is it? There is nothing after it. So how anything can learn from it? Okay. For learning, at least we required a feature and a label. Right. That's why we are using I plus 1. That means I value will be 1, 1 plus 1, 2. Right. So take two value, first take two value, then take three value, then four, five, right? So that is done. Okay. So we create a sequence of words over here. All right. Okay. Now the sequence of what is created, this one I can store into, let's say, take this thing, I commented it, and this one I can store into a particular variable called n-gram sequences. Okay. We just store into n-gram sequences. Okay. And this value we will store somewhere, which is called a separate list. Okay. So let's say my input sequences is equals to a blank list, and in this blank list I have to store all these values, right? So my blank list dot append, okay, what I have to append? I have to append this thing. Done. Okay, and then at the end I'll print my input sequences. So my input sequences was blank. Initially it was just blank, nothing is there. But later on we are appending everything over here. So it got everything stored over here. All right. Okay. So my data is prepared, not prepared. It is somewhat prepared because, now I have to do the padding, right? Because I have right now 99 and 4. Okay. Thereafter 99, 4 and 177. Okay, thereafter 99, 4 and 177, and then 50. Okay, then 99, 4, 177, 50, and then 34. Okay, so we have this thing created. This is our label. Okay, but features are what? Not structured. So we have to do the padding over here. Then only it would be better. Okay. So padding depends upon what? Padding depends upon what is the maximum length of the sentence, which sentence is longest. Okay. If it is 5, then all of them should be 5. Okay. If it is 10, then all of should be 10. If it is 20, then all of them should be 20. So I have to find out which is longest over here. Okay. So what I do? I'll run a loop over here for sequences in my input sequences, access each sequence one by one. Okay, we are just accessing each sequence one by one. Print length of sequences. Print what? The length of sequences. So here we get the length of each sequences, right? Spelling is sequence, sequence, right? So length of, access each sequence one by one and print the length of each sequence, right? So here, the first one is obviously 2, then 3, then 4, then 5 kind of thing, right? So here we have each word. Here we have the things like this: 2, 3, 4, 5, 6, 7, like that. Okay. So if I have this thing, thereafter what we do? We can just store these values, these length into a particular list. I will give it a name, sequence length. Leng, sequence length. Sequence length is blank. So this sequence length I will store over here. Dot append. Okay, dot append is something which will store these values. Now, if you know Python, it's good. If you not that much aware with the Python, let me tell you, list is a kind of a data structure in Python which stores multiple sequential value, right? So here I have a blank list and I want to store all these information into that list. So first, length is calculated 2, So that too, when we use append function, when we use what append function, this 2 will stored over here. Thereafter, the next sequence length is calculated, which is 3. So 3 will be stored over here. Then next sequence length will be calculated 4. So 4 will be stored over here. Next sequence length will be calculated 5. So 5 will be stored over here like that. Right. So in this way, all the sequence length is stored. So if you see the first sentence having the 55 words, then again second sentence is started. So second sentence is having what 40 words. Then third sentence is started. Right. So we are just storing everything over here. All right. So once these are stored, I'll just comment it. I will find out print sequence length. So sequence length we have is what? This one, like this. Now I'll find out the maximum of it. Okay. So maximum of the sequence length is 83. That means we have to do the padding so that all of them will become 83. Okay, all of like this is 2, so this should be of length 83. So we have to add 81 zeros before 99. All right. So let's import over here from TensorFlow dot Keras dot pre-processing import pad sequences. This is what we used last time as well. And we have to do what? In this pad sequences, we have to feed 3 parameters. Okay. What are those three parameters? The first parameter is what? If you see over here, we had used it. The first parameter is sequences. Okay. So sequences is what? My input sequences. Okay. Second parameter is maximum length, which is 83. Okay. And third is pre-padding or post-padding. Uh-oh. Something is incorrect. Huh? What is incorrect? If the import is failing due to missing package, you can from TensorFlow.Keras. Okay. One thing is missing. Dot sequences. Dot sequence. Okay. So done. Okay. So my text data is converted into numerical form when we are ready with it. And this we can name as input sequences. Input sequences. That's it. Okay. Now from this input sequence, I have to do what? I have to pick the last column as a target column. Okay. And rest all will be the feature column. All right. So that we can use it in the neural network later on. All right. So the last step that we have to do what? I have to define over here. Okay, we also need to import NumPy because we have to work on the matrix, and whenever I have to work on the matrix, okay, in Python we require a library called NumPy. So what is X over here? X is my feature, right? So what is feature? Everything, not the last column. I want everything, but I don't want the last column. See, if I want the last column, so I have to run over here input sequences, okay, comma, colon, and colon. Now what is this? This process is called slicing your data. This process is called what? Slicing your data. Now I have to slice only the last column. So I'll use -1. -1 represents the last. Okay. Why I'm giving -1 over here? Why I'm not giving -1 here? Because if you have an array, Then first before comma, that is used for row slicing. Okay, and after comma, that is used for column slicing. So I have to do this column slicing, right? I don't have to do the row slicing. Okay, I have to do what? I have to do column slicing. I need a last column. So it's like -1. Okay, so -1 colon. That means from -1, like say I've used -2 over here. So if I use -2, that means what? From the -2, okay, this is what? -1. This is -1. This is -2. So from -2, I want everything. Okay, that's why -2 colon. All right. So -2 colon. That means from -2, I want what? Everything. Right. But I want last column, so -1 colon. So this will be considered as what? Your target column. Right. That is your Y. So Y we captured. Okay. Now X. What is X? X is like I want everything but not last column. Okay. So in that case, we can just use over here. Oh, wait a minute. Okay. In such case, we can use here what? I want everything but not want the last column. So here, let's say I'll use -1. So it is giving me just -1 I kept here. That means just before -1 I want everything. I don't want -1. That is last one I don't want. Right. So here it's like slicing we are doing. Like this. Okay. So I have X and Y defined properly. Okay. Now we have to use this information to train your model. But before we use this information, let me check the shape of it. So the shape of X is 1371 and shape of Y is what? 1371, obviously. All right. Okay. So here we just created our features and labels. Next, we have to do what? We have to just build a model which can predict the next word. All right. We are halfway done. Only we have halfway left. Okay. So let's build the model. So how do we build the model? Model is equals to, okay, for building of the model, what I told you last time. Last time I told you we need a library called from Keras dot from TensorFlow.keras import models. So this is what we'll import once again. Then we define model is equals to models dot sequential. That means I want to create a sequential model over here. This models dot sequential. Okay. And then we can do what? We can add the layer which will perform the embedding. Okay, because we have to convert these numbers into word vector. So this is a layer we added which is basically creating the embedding. So I'll just copy and paste it. Input dimension will be equals to what? Input dimension will be equals to total number of words that we are using. Okay, what is the total number of words? This is what we have. So this is your total number of words. Okay, that would be converted into output dimension that we can choose. Let's say output dimension, if I'm making it 16, that means each word will be defined by a vector of size 16. All right, like we did last time. Now input length will be equals to the maximum length that we have. Okay, what is the length of it? 82. Okay, 82, right? So it's like 82. All right. Now after this, what we did? After this, we created the deep neural network. But now you have to create RNN. So if I have to create RNN, again we can make use of the same Keras. Here we'll just add layers dot simple RNN. Just call it simple RNN. And this guy will create our RNN architecture that I told you over here. Okay, this architecture will be created. Now, how many units we require? As many words we have. We have maximum 82 words. So maximum 82 units. Okay. Now we have to create the output layer which can predict the word. Okay. So here we will use what? Model dot add layers dot dense. Okay. So if I have to predict one word, let it be one. It is not correct, but still let it be. Later on, I'll explain you summary. Okay. This is not the exactly correct neural network we prepared, but yeah, there are few modifications we have to do. That modifications I'll let you know that what kind of modification required. But first, let's try to build this model so that we can understand the limitations of it. So next we have to compile. So for compilation, what I told you, what required? Three things required. One is called optimizer, other is called loss, and third is called accuracy that we want to evaluate. Okay. All right. Now we will just fit the data. Model dot fit. What I have to fit? I have to fit x comma y, and I have to define epochs. How many times I want to train this simple RNN model. So epochs, let's say I will use 20. Or let's say 100. Okay, it will be 100. Let's see how much time it is taking. So now it will start the training. So accuracy is 4%, 1%, 6%, very poor. Okay, 6%, 4%. It's a very poor accuracy that we are getting. Okay. So we will see how can we fix it, but let it be done first. Okay, 29, 40. It is not improving. Like last time, my accuracy goes to what? 100%, but this time it is not improving. There is a reason behind it why it is not improving. It remained close to 5 to 6%, right? See what happened when we are using this model. Okay, what are we doing? We are feeding this data as a input data up to here. Okay, we are using this data as a input data up to here, up to this place. This is your feature. Okay, and this is your target. So target value is what, like 99, 4, 170. It can be anything. It is anything. Okay, it is not like last time 0 or 1. Okay, last time it was just 0 or 1. As it was 0 or 1, so what we did last time, we had used the activation function called sigmoid, right? So sigmoid was doing what? Was actually converting the last neuron value Okay, in the range of 0 to 1. This sigmoid was converting the last neuron value in the range of 0 to 1. Okay, the formula that I explained. Okay, and that's why error optimization were easier. Okay, model can optimize the error more easily. But here it is not like that. Here we can't use sigmoid. Okay, here we can't use sigmoid because the output is not 0 to 1. It is anything. But if I can't use sigmoid and it is expected to learn the next value, but it is not learning. It is not learning at all. Right. So shall we increase the number of number of this thing, that is word vector? Because if I increase the word vector, I'll increase the weights. No, because error is accuracy is very poor. Okay, somehow if you increase, you can make it 10%. Right? Accuracy is very poor. So what do? We will go for the another approach. What is another approach? The approach is we have to do something so that output neuron value can be 0 or 1. Okay, that means I have to convert this thing, which thing? The target column. Okay, the target column. This target column somehow I have to convert it into 0 or 1. So how it can be converted into 0 or 1? Let's see. If I have a number like this, 1, 2, 3, 4, 5, 6. Okay, I can represent this guy like this. This is what I told you. This is called what? One hot encoding. We already did it because to convert a word into a vector, this is your first thing happen. Okay, this is your first thing happen which converts the word into a vector. Right, now we will use the same thing for my target column. Okay, what we do, we will use the same thing for my target column. That means I will implement the one hot encoding for the target column. All right, let's see. Here we will import a library from Keras.utils. We already used this library earlier. Import to categorical. Okay, now we will use to categorical. All right, so here this thing will be has been converted to this form, right? Here we just converted y into what? One hot encoding form. Okay, using two categorical, right? So what is yt? See, if I will call yt over here, the yt is, let's take the any single sample of yt. So this is a single sample of yt in which only one value is 1. That is the first sample. Okay, this is the first sample of yt in which only one value is 1, rest all are 0. Okay, right? So now why we did it? Because now we will try to build, the neural network model will work like this. Okay, see, after any particular word, let's say after following, okay, after following, how many words are possible? We have 590 words in the data. How many words are there in the data? We have five. How many words are there? Let's check. We have 5. Oh, where it is? I can't find it out. Total number of words. 599. Okay. We have one is added. That is okay, fine. So we have 599 words are possible after following 599 words. Okay. Now, as 599 words are there, we have converted any single word. Let's say word 3. Okay. This is converted like this 0, 1, 2, 3. And then we have 0, 0, 0, 0, 0, 0. Total 599. Okay. Sorry, I'm just breaking the connection gets breakdown. There is some problem happening over here. Just allow me for a minute. Just give me 1 minute. Sorry, some connection, some network issues are there. Okay, fine. So, after the following, there are 599 words are possible. So we create the neuron of each word for each possible word. Okay. We create the neuron for each possible word. That is 599 possible words. So 599 output neurons. How many output neurons? 599 output neurons we will create. All right. So now if there is a word like 3. So for 3, that model needs to learn how to predict 3. So model if needs to learn how to predict 3, so model will try to learn to maximize this particular neuron value. Because this neuron value needs to be 1 if 3 to be predicted. If 3 to be predicted, then this neuron value should be maximum and other neuron value should be lesser, because this neuron value should be closer to 1. Another neuron value should be closer to 0. Okay. Same way, if a model needs to predict, okay, if for a particular sequence of data, if it needs to predict the next word as 7, okay, if it needs to predict the next word as 7, then it will try to maximize 0, 1, 2, 3, 4, 5, 6. It needs to maximize this particular neuron value, right? That's why we did over here one hot encoding. Okay, so that we can create over here, so we can create the number of output neurons equals to number of possible words. Okay, so now if I'll check the shape of yt, that is 599. That means the output neuron value over here, okay, the output neuron value that will be present over here will be equals to 599. Okay, and now out of all the possible neurons, there will be one neuron which will maximize and will go close to 1. So here also I have to use the function called activation function called sigmoid. Okay, just like yesterday. So now if I will build it and will try to train it, now I have to use YT over here. Okay. So something is incorrect. Let me just run on. Okay. So now I did this thing. Is it accuracy better? Still it is 7%. It should improve. It's not improving. Let me try with, since it is multiple categories are there. So let me try with categorical cross entropy. This is what that when we have just two category, then we use binary cross entropy. But if I have multiple category, we can use categorical cross entropy. So almost it is done. Only we have to build, we have to see how can we predict the next word. But for this, that whole process, first it should have accuracy at least 90% or something, but it's not improving. As it is not improving, I'll stop it, interrupt the execution. And after interrupting the execution, I'll again execute it with categorical cross entropy. Any other change I should do? I don't think I should do any other change over here. There is one more change I have to do, but for doing that change, I have to explain something. As of now, let it be like this. Let me check with categorical cross entropy. No, it's not going good. Okay, so this accuracy, we will take this accuracy to up to, okay, now it is improving. Yeah, good. I thought it will not improve. Now it is improving. Right. So now it goes to 23%. Now it will go to 90%, close to 90%. Easily it will go to 90%. Okay. So my model is now created, having a good accuracy. Only we have to check how these guys can be used for the to generate the next word or predict the next word. So next word prediction I will not do today. Okay, that we'll do tomorrow. So that I can again explain all these things once again to you. Okay. And once we did finish it, thereafter we will work on the transformer architecture, and then we will move to the GPT and all. Okay. So I'll share this file with you in your classroom. But before that, let me share here as well. Okay. Just work on it, and tomorrow we'll work on the prediction. The accuracy goes to 98-99%. So this is it for the day. Let's meet tomorrow on the same time and to get ahead from here. If you have to ask anything, please let me know before closing for the day. Done. So finally, it closed at 98%. Fine. So we'll meet tomorrow same time. We'll try to finish it. Thank you everyone. Take care. Good night.